Okay, so here's the thing you want to know about moles. Think of a mole like a dozen. You could turn a dozen into a number of eggs, 12 eggs, or into a number of grams, depending on the ratio of the mass of the eggs to the egg. So, same thing with moles. Think of moles like a chemist's dozen. Because our eggs, atoms, are much smaller, we have to have more than 12. We have 6.02 times 10 to the 23rd of them. The idea is, if I have 6.02 times 10 to the 23rd atoms of, I don't know, say hydrogen, it will have a mass of 1 gram. But if I have 6.02 times 10 to the 23rd atoms of helium, it has a mass of 4 grams. And if I had this many atoms of neon, it has a mass of 20 grams. Now I'm going to take these atomic mass values and I'm going to round them to whole numbers just to make life easier. So let's go ahead and get started here. The thing to remember is you can turn moles into grams, or you can turn moles into particles, and if I wanted to turn particles into grams, what I do is I turn particles into moles and then moles into grams. It's basically using the factor label conversion method we used at the beginning of the year. So let's get started. So the first thing you want to do is write down the amount of stuff you have. So what we have here is 7.3 moles, and we abbreviate moles that way, save ourselves a little effort. Multiply, draw a fraction line, and put the thing you don't want in the basement, which is moles. Now, what do I want to convert moles to? I want to convert moles into atoms. So I want to go from here to here, which means this is what I'm turning it into. So I'm going to put atoms up above, and 1 mole is equal to 6.02 E23. So that doesn't look so great. And when I multiply that through, what I'm going to come up with is 4.4 times 10 to the 24th atoms. Okay. Now let's try the next one. It says, what is the mass of this many moles? Now, anytime you're asked to find mass, that's when you go to your periodic table. Notice here I didn't have to go to my periodic table because I wasn't asked about mass. If I want to know mass, that's when I consult the periodic table, because these mass numbers tell me the mass of 1 mole of each substance. So let me just move this out of the way a little bit here. Alright, I'm going to make it a little bit bigger. Alright, what is the mass of 55.5 moles of aluminum? So I start off with 55.5 moles. And I don't want moles, so I put moles in the basement. I want grams, so I put up above. Now, 1 mole of aluminum is how many grams? I look at my periodic table and I see it's 27 grams. So I'm going to put 27 up above. And I'm going to say equals. And what I'm going to do is I'm going to multiply 55.5 times 27 divided by 1. And when I do that, I'll get 1,498.5 grams. Let's keep going. I don't know about you, but I love moles. Alright, and I'm going to make this a little bit bigger. Alright, and give myself some room to work. Okay, now, how many moles are there in 187 grams of sulfur? So I'm going to start off with what I know, 187 grams. So I'm going to write 187 grams. I don't want grams, so I multiply and I put grams in the basement. So remember, whatever unit you have here has to go down here. What can I turn grams into? Well, if I look at the top of the periodic table, I'll see I can turn grams, right here, I can turn grams into moles. So that's what I'm going to do. By golly, I'm going to put moles up above. Now, anytime I want to convert moles into grams, I have to use the periodic table. So, one mole of sulfur, remember it's sulfur, if I had to look at the periodic table, here's sulfur, It looks like 1 mole of it, I'm going to round that to 32 grams. Is 32 grams. And I was asked to find how many moles, and I have moles up above. And once you get what you want up above, you just put an equal sign. And you're simply going to say 187 times 1 divided by 32 equals. And when I do that, what I'm going to come up with is 5.84 moles. Now we get a little bit trickier. Now I'm going to say how many atoms are there in 76 grams. So in this case, let's look at what I have to do. Now what I'm going to do is I'm going to take grams, turn grams into moles, and then turn moles into particles. So remember, for grams I have to look at the periodic table. Particles are always equal to 6.02, and moles in most cases is equal to 1, but we'll talk about that later. So let's try this now. So I'll start with what I know, 76 grams. 76 grams. I don't want grams, so I'm going to put them in the basement. What can I turn grams into? I can turn grams into moles. If I'm going to turn grams into moles, I got to look at the periodic table. Now I'm talking about gold, so I come down here, find gold, and it looks to me like gold is 197 grams, is what I'm going to round that to. 1 mole of gold is 197 grams. But I don't want moles, so I'm going to multiply, draw a fraction, and put the thing I don't want in the basement. I don't want moles, so I'm going to put moles in the basement. And I am going to put atoms up above. Now, anytime I turn moles into particles, I remember this. 1 mole is equal to 6.02 times 10 to the 23rd particles. Just like a dozen eggs is always equal to 12 eggs, or a dozen donuts is 12 donuts, or a dozen hamsters is 12 hamsters, 1 mole of anything is always equal to 6.2 times 10 to the 23rd of those things. Now that I've got what I want on top, atoms, which is what I was looking for, I'm going to multiply. So I'm going to say 76 times 1 times 6.2 times 10 to the 23rd divided by 197 divided by 1. And what does that equal? And multiply it through, and I'm going to come up with 2.3 times 10 to the 23rd atoms. Now, man, I love doing this. Let's try another one. Ooh, determine the formula weight, which is also known as the molar mass, which is also known as the formula mass. But let's just go ahead and do this. What you have to do is this. You have to look up what is the mass of 1 mole of nitrogen. So if I look at my periodic table, nitrogen is 14, so I'm going to say it's going to be 14 grams plus, I have 3 iodine, so I had to say 3 times this. So I'm going to say plus 3 times, and iodine is 127. 127. So if I multiply 127 by 3 and then add 14 to it, here's what I get. 395 grams. That is the mass of 1 mole of nitrogen triiodide molecules. Which, by the way, you're going to love nitrogen triiodide when you get to it. It explodes when you touch it. But let's keep going. The next one is copper hydroxide. So, copper has a formula weight of, this is a 5, so I'm going to round that to 64. I'm going to say 64 plus, now let's see what here. I've got 2 oxygens and 2 hydrogens. So I'm going to say, you know what, I'm just going to do it right here. I say, well, if oxygen is 16, 2 times 16 is 32. I got that by multiplying oxygen by 2. And now hydrogen is 1, so 1 times 2, that's pretty easy. That's 2. Add all those up, and what you come up with is 98 grams. is the formula weight of copper hydroxide. Let's just get trickier now. Okay. Aluminum sulfate. Whoops, I didn't mean to do that. Oh, I didn't mean to do that either. No, stop it, Eric. No, what'd I do? Mommy, help. Okay, so what I have here is I have 2 aluminums, and each aluminum has a mass of 27. So 27 times 2, that's 54. So I have 54 grams of aluminum, plus I have 3 sulfurs, and sulfur is 32, so 3 times 32 is 96, so I'm going to say 96, plus, are you ready for this? I probably can't do this one in my head, but I'm going to try, plus I have 3 times 4, that's 12 moles of oxygen, and oxygen is 16. And you know what? I don't know what that is, so I'm just going to do this. I'm going to say, okay, it's 12 times 16. And when I run all that through, what I come up with is 180. Is that right? No, that's not right. It's 342. 342 grams. Alright, next one here is sugar, C6H12O6. So, let's see what I've got. I have 6 moles of carbon. So I have 6 times 12. That's going to be 72 grams for my carbon. Now I have 12 moles of hydrogen. So 12 times 1 is 12. Plus, I have 6 moles of oxygen. So I have 6 times 16, and that's 96. Add all that up, and you come up with 180 grams as the formula weight of sugar. Alright, now let's start doing it more the way we really see it, where we're dealing with compounds instead of atoms, or elements rather. So, my question is, what is the mass of 2.5 moles of this? So, I probably shouldn't have moved it quite so far. I can move this down for right now. So, wasn't it nice of me to use something we already calculated the formula weight of? The formula weight of this is right here. See? So, I'm always going to start off with what I know. So, I'm going to start off by writing 2.5 moles. And I don't want moles, so I'm going to put moles in the basement. 1 mole of this equals how many grams? Well, 1 mole of nitrogen triiodide is 395 grams. Its formula weight, 395. So I just say 2.5 times 395 divided by 1. And when I do that, I'm going to get 987.5 grams of the stuff. And that's pretty amazing when you consider like even a couple grams of it is pretty dangerous. Well, let's look here now. I can move this down a bit, I think. How many molecules, so I'm looking for particles, are there in a spoonful of sugar, which is this many grams? So I always start off with what I know, 5.6 grams. So I'm going to say 5.6 grams, and I'm going to multiply and put the thing I've got, grams, in the basement. You know what I can turn grams into? I can turn grams into moles. Now, it turns out that 1 mole of sugar is 180 grams. So I'm going to write 180. That gave me moles, but I don't want moles. I want molecules. So where do I put the things I don't want? I put them in the basement. Because I didn't want moles, I put them in the basement. What can I turn moles into? Well, I can turn it into molecules because that's a kind of particle, and I can turn moles into particles. So I'm going to say molecule. And 1 mole equals 6.02 times 10 to the 23rd molecules. Now that I've got what I want on top, molecules, I go ahead and multiply. 5.6 times 1 times 6.02 times 10 to the 23rd divided by 180 divided by 1. And when I do that, what I get is 1.9 times 10 to the 22nd molecules. It's a terrible molecule. Look at that. I should be ashamed of myself. Let's just move this up. What is the mass of one molecule of sugar? Well, I start with a number I know. 1 molecule. I don't want molecules, so I'll put it in the basement. Now, here's what I know. I want to turn, in order to do this, I want to get to grams. I'm trying to basically get from particles to grams, which means I have to go through moles. See what I mean? I'm trying to get from particles, which I have, well, what did I just do? I have 1 particle, and I'm trying to get to grams, which means I'm doing particles to moles, and then moles to grams. Like this. Alright, here we are. So I'm going to turn molecules to moles. 1 mole equals, how many molecules, kids? 6.02 times 10 to the 23rd. And that's a terrible looking 6. I'm sorry about that. Alright, now I don't want molecules. I want grams. So I'm going to put moles down below. 1 mole of sugar equals, says right here, 180 grams. Now, I should have it set up right. I'm going to go from molecules, turn molecules into moles, get rid of moles, turn them into grams. So I'm going to say 1 times 1 divided by 6.2 times 10 to the 23rd times 80. And when I do all that, what I'm going to come up with is 2.99 times 10 to the negative 22 grams. It doesn't weigh a whole lot now, does it? Oh, look at this. Alright, it's going to get a little bit tricky. Oops, didn't mean to do that. Let me erase that. Alright. Okay, kids, here's as tricky as it gets. The question is, how many oxygen atoms are there in 22 grams of this? So in this case, I'm trying to take a compound and pull out one of the component elements. This is actually something we need to do a bit in chemistry. So fortunately, it's pretty straightforward. We had to add one more step. As always, I start with the thing I know. 22 grams. And I move this periodic table out of the way. I don't want grams, so I put them in the basement. I can turn grams into moles. Now I got to know how many grams there are in 1 mole of this, which means I'm going to have to go up here and take a peek. It looks like it is 98 is what it is. 98 grams is what 1 mole of this equals. Alright, good to know. So I'm going to put 98 here. Now look at, here's the trick, kids. Watch this. Now that I have moles, you can turn moles of compound into moles of constituent element. So what I'm going to say here is, I'm going to add this extra step where I'm going to say, alright, in 1 mole of this compound, there are 2 moles of oxygen atoms. Right? And so basically, I've now pulled out the oxygen from it. Now I don't want moles of oxygen, so I multiply, and I'm going to put a fraction line, and I'm going to put, I'm going to say 1 mole, and I could put O here for oxygen in case I forget what I'm talking about. I look at my periodic table, a mole of oxygen equals, oh darn it, you know what, I wasn't asked for what the mass is, I wonder how many atoms. So I'm going to convert it to atoms. And you know what 1 mole always equals? You guessed it, 6.02 times 10 to the 23rd. So I'm going to put in 22 times 1 divided by 98 times 2 divided by 1 times 6.2 times 10 to the 23rd divided by 1. When I do that, I'm going to come up with 2.7 times 10 to the 23rd atoms of oxygen. It just gets harder and harder, huh? Look at this next one. How many grams of oxygen are there? Well, I had to do this. I had to start off with what I know, 22 grams of aluminum sulfate. So I'm going to say 22 grams. I don't want grams. I put them in the basement. The one thing I turn grams into is moles. 1 mole of aluminum sulfate equals its formula weight, which I don't remember what it is. Let's see what it is. It is right here. It is 342 grams equals the formula weight of aluminum sulfate. 342. Help me remember that. 342. So 342 grams equals 1 mole of aluminum sulfate. But what I want is grams of oxygen. So I'm going to try to pull the oxygen out of here. So once I've got things in a moles, I can turn it into anything I want. So moles are very flexible. So I'm going to put moles in the basement. And I'm going to say, in 1 mole of this compound, there are 3 sets of 4, which is to say 12 oxygens. 3 times 4 gives me 12. There are 12 moles of oxygen. And if it helps you write comp here, go ahead and do it. Alright, now I have moles of oxygen, which I don't want. So I'm going to put moles of oxygen down below. 1 mole of oxygen equals, if I look at my periodic table, I'll see it's 16 grams. So 22 times 1 divided by 340, is that a 3 or a 2? I forget. I think it's a 2. Times 12 divided by 1 times 16 divided by 1. Do all that, and what you're going to come up with is 12.4 grams. You know you've done it right if you end up with less than this. If you end up with more grams of a constituent element than you have the entire compound, you know you screwed up. Alright, we just have one last one to do, and we're going to be in good shape here. How many grams of iodine in 8.8 times 10 to the 24th molecules of this? So, I start off with what I know. 8.8 times 10 to the 24th. Sorry that did not end up as a superscript like it should have been. Okay, now let's see, that is molecules. So I don't want molecules. I better write it so I don't forget. Molecule. I don't want molecules, so I'm going to put molecules in the basement. And one thing I turn molecules into is moles. 1 mole equals how many molecules? Let's see. Gosh, oh yes. 6.02 times 10 to the 23rd. Again. Now you maybe see why Mole Day is celebrated at 6:02 a.m. on October 23rd. Because chemistry teachers really think this is a cool thing. Now, I don't want moles. I want grams of iodine. So I'm going to say in 1 mole of this compound, there are 3 moles of iodine. 3 moles iodine. I don't want moles of iodine, so I'm going to say 1 mole of iodine equals how many grams? Well, okay, is it like 127 or something like that? Hey, it is. How about that? 127. How absolutely nerdy of me. 127 grams. Now that I got what I want on top, I was looking for grams. I've got grams. I'm just going to multiply this times this times this times this, divided by this, divided by this, divided by this. And if I was you, I would skip the ones because it won't make any difference. When I do this, when I multiply all this through, what I'll find is If I have that many molecules of nitrogen triiodide, I have 5,569 grams of iodine. Well, excuse me for yawning. Hey, I love moles. I love a good mole, and I hope you do too. See me for help if you need it. Check you later. Bye.